Greetings everyone. In the last video I put this Radio Shack Realistic SA-150 integrated stereo amplifier on the analyzer and measured some of its performance specs. And not surprisingly, it's not a real high-powered amp. At 8 ohms we got just over 2 watts before it started into clipping at a reasonable 0.1% distortion. And I took a look at a bunch of other measurements. But today I want to modify this thing. I want to see if I can improve its performance a little bit. I want to see if I can get a little more power out of it. Make it usable with 4 ohm loads. See what kind of power we can get there. So let's take a look at some of the mods I have planned. First up, in the power amplifier section of this unit, I'm going to change out some of the capacitors. Starting at the power supply, for some reason they used a 1000, you can see it there, 1000 microfarad cap supply ripple filter, which is to me a little bit weak. I don't know why they went that way, but I'm going to improve that. So I went through my piles of capacitors. These are all recovered. I know a lot of them came out of DirecTV satellite boxes. My parents had it, and when they quit the service, they didn't want the boxes back, so perfect thing for harvesting parts. And I got some parts out of some other stuff as well. But anyhow, I'm going to replace that 1000 microfarad 25 volt with this. Looks like a United Chemicon brand. 25 volts, 4700 microfarads. I've tested the ESR and value of this, and it's good. So that's the first thing. Then I'm going to change the output coupling capacitors. They are 1000 microfarad, 16 volt, and I'm going to replace them with these Rubicons here I found. 16 volt, 2200. That should improve the low end frequency response. It did roll off a bit early, I think. While it's not going to be audiophile flat, it's going to improve the bass response considerably. Next, I'm going to replace the input coupling caps. For some reason they used 0.22 microfarad electrolytic capacitors. Not sure why they did that, but probably a money thing. But the input impedance of this chip is 30 kilohertz. And if you do the math, that rolls it off at 24 hertz. I mean, the output caps also contribute to the early roll-off, but why would you hamstring the amp with such weak input? So I'm going to replace it with these film 1 microfarad caps, and that'll lower the roll-off, at least at the input, down to single digits. And that's what you usually want to see in a hi-fi amp anyway, but like I say, it's not going to actually get that far, especially at 4 ohms, because of the output coupling caps. I don't know if I have room to stick anything bigger than 2200. Not sure I really have anything larger, but yeah, I think that's plenty for this little amp here. The other caps on the amplifier, there's feedback caps. They use decent values there. ESR is not critical. That's a supply rejection cap. It rejects ripple. It's kind of a part of a circuit that has some reference voltages inside, and they want to filter that, make sure it's pretty clean. And you have some bootstrap capacitors here. Same deal, they don't have to have low ESR. As long as they're good, they're fine, don't need to be replaced. The phono section of this amp, which is up here, I'm not going to monkey with that. It seemed to work okay, and it doesn't really need anything done to it. However, I am going to remove the loudness contour function of the volume control here. As you saw in the last video, it does have a loudness contour. At lower volumes it boosts the bass and the highs. And none of my other amps I've built or have had used the loudness contour. It's kind of a preference thing if you want that or not. I don't really want that. The speakers I have are fairly large and deliver decent bass. And I know it has to do with human hearing, you know, to boost the bass at lower volumes and the highs, so it sounds more proper. But yeah, like I said, I've never had it in my other amps and don't really want it, so it's going to get deleted. To remove it, I have to pull these caps. The way the filter is connected to the volume control, I just can't cut off that one tap. I have to pull the caps because there's like an RC filter and that taps between those, and if I don't take that out, you'll still have a curve, or I should say it'll still have an effect on the sound. So, oh, and I almost forgot to mention that I'm going to add an additional heat sink here to improve thermal dissipation. Even with 8 ohm loads, after running it a while, I put my finger here, almost too hot to touch, because the steel heat sinking they're using now, just into the chassis, it's not adequate. And if I want to use this thing with 4 ohm loads, I need some better heat sinking. So I made a little heat sink here. It's going to fit at this point. I have to drill to get around that hole there, but I'll place this heat sinking here, and it will improve the thermal dissipation adequate enough for 4 ohm use. Okay, so now I'll turn off the camera and turn on the soldering iron and get busy. Progress so far, I have all the new caps in the amplifier section there. There's the films and the loudness contour caps have been removed. Those resistors are part of the RC network that made up that loudness compensation circuit, and well, they're isolated now without the caps. They're not really connected to anything, so they're not going to affect the sound in any way. So when I selected these caps, I went looking for the lowest ESR ones I had, and I used my little tester here to check the ESR, and these Rubicons were the lowest ESR ones I had. I had some other ones, but they're a little bit higher. Being output coupling caps, I wanted the lowest ESR I could find. And of course, all these test fine. Again, there's really nothing wrong with these caps. The amplifier was working fine. It's just the value of them were kind of low. I mean, 1000 microfarad ripple cap on an amplifier is a bit low. Okay, so I'll continue here and get the heatsink installed. Okay, to attach the heatsink, I'm using this thermal transfer tape. This 3M double-sided heatsink tape. There's the part number. I like this stuff. I've used it a lot, attaching cob LEDs to heat sinks, small heat sinks to the board. I filed this to make sure there's no high spots. So I'll position that, take the blue masking off, and stick the heatsink on there, and it'll hold it. It won't come off. Alright, the heatsink is installed. That's not going anywhere. Now let's hook it up and see if it works. Okay, I'm seeing good things already. So this is the kickoff test. 1 watt into 8 ohms at 1 kilohertz. If you remember from the last video, I was around 0.08%. Now it's 0.04%. So that's improved. Also, this 120 hertz marker here, this little node here, it was up around 40, minus 40 dB before, but now it's, you know, not quite down to minus 60. Let's see, that's minus 50 there. So yeah, it's below 60. It's like minus 65 or something. So huge improvement there with that larger cap. So yeah, two things looking better already. Okay, frequency response. And we got something interesting going on here. At the high end, we got this peak at over 20 kilohertz. I mean, it's not huge, it's 2 dB. I have 1 kilohertz set at 0 reference here. So that's interesting. When I tested this amplifier before, I had its tone control turned all the way up, give me the flat response. So volume control's fully open, so something weird is going on here. However, down here at the low end, you can see we're 3 dB down now at 17 or 18 hertz, so that's much improved over what it was before. But I need to figure out what this is all about here. It must be some sort of high pass going on here I need to look at. Then it rolls off. Well, the heatsink's doing its job. That's nice and warm. But anyway, with these caps, see, here's the tone control. I got it wide open. Maybe I should try turning it down a bit. Look at these caps here. And another set of caps here, so I'm not sure what's going on. I'm going to have to look at the traces. Maybe I can see if I can find a schematic for this thing. But what if I turn this tone control down a bit? Okay, so this is what I'm getting with the tone control set to 0 or center position. It's doing its job. It's rolling the signal off at higher frequencies, but that we're still getting that bump here. So there's another filter or something in that circuit causing that. It's like a high pass filter. Then there's another low pass set at a high frequency to keep higher frequencies out of the amplifier. But yeah, we're getting, it kind of forms like a band pass, a low Q band pass or something like that. Now, poking around, I found a schematic, and I also learned that there's different versions of this amplifier, and I can tell by looking at some pictures. The phono stage in mine is different from this one. See, power comes in and goes to an RC, then it goes to another RC network, then that powers the phono stage. But this amp, it only has one cap here. On the other ones, there's two caps. But this one uses Zener regulator. See, there's a current limiting resistor, then the Zener regulator, then the filter cap. So yeah, it's a little different. And the date, come on, focus. Where did I see that date code? Yeah, 8915. 8910. So it's made early in, well, these caps were at least 1989. So yeah, this is a slightly later version of the amp, maybe. See, there's no Zener regulator on this, the power input to the phono stage on this one. Also showing that coil L101. I don't see that in this amp. The filter cap is 2200, 2200 microfarads, where the one I pulled out of this amp was only 1000 microfarads, and it looks original. I mean, the brand of these caps are the same. So yeah, I'll poke around here and I might pull some resistors, or some capacitors, see if I can flatten that out. Okay, so this is our tone control. As we rotate it this way, the wipers go towards this side. So back here is the control connections, and that's ground. So that side of the control goes to ground. Those are the wipers in the middle. Let's see what's going on here. And this is where it's good to have a schematic. Tone control. Okay. So as you turn it higher, yeah, that makes sense. As you turn it higher, you're just grounding out this cap, so it's just pure resistance. As you turn it lower, you're moving the wiper up, putting that cap into the circuit, and it's shunting way more and more high frequency as you turn this control down, which moves this wiper up on the schematic more towards the signal side here. Okay, so the wiper arm shows the capacitor connected to it. I have the power turned off. Let's see, this trace goes here, ends right there, and this trace ends right here. And that's ground because it's connected to the chassis. So, let's see. Get my bearings here. Okay, yeah, that's the tone. And yeah, right here, these are the tone control caps. Then we got these. And this is that thing I was looking at before. We're shunting frequency around. I'm not seeing these caps. Well, whichever one those are, I have to look closely. From there, it goes into the input coupling caps. Those are the 0.22s that are now 1 microfarad. They got this high pass going around this, bypassing the balance. Why is the balance showing grounded? That doesn't really make sense. That should just balance it. Okay, I've been poking around here and trying to look at some components. Here's R139 and R140 on the other channel. They're 12K resistors. You see there's this cap in parallel with it. But I go over here, there's R139 and 140, 12K. I don't see any component in parallel with it, unless it's hiding from me. But looking around, I'm not seeing those part numbers. So maybe they omitted this cap on this version of the amp. However, here's R137 in parallel with C125, and the complements over here on the other channel, 138 and 126. And that is those guys there. There's C126, R138, C125, R137. Is that what I'm looking at? Yeah, 137. And 138. Make sure I'm... Yep. So if you notice, that's letting high frequency right by here. And this is the input coupling cap of the amp, 0.22, which was replaced with 1. If I didn't mention that earlier, this is just a RF cap. It just shunts RF to ground so it doesn't get into the amplifier. So yeah, apparently this is omitted and this is letting that signal through. So I believe if I take those out, that would get rid of that big bump. I mean, what else here is going to do that? Unless there's something earlier. See, I pulled these caps out, so there's no connection to this loudness contour on both sides. Yeah, I think if I pull that out, that would correct that hump. Let's do it. Okay, I pulled those guys out of there. And we are back to flat. Let's see here, let me get you pointed at the screen. And we're still having that high frequency imbalance. See, everything down here is pretty close. I mean, that's like 20th of a dB off. Why is it like that? I think it's that RF blocking cap. One must be a little more aggressive than the other. They're ceramic caps. They probably have pretty wide tolerance. I can monkey with that. I don't think I'm going to. But yeah, this is now flat. You know, hang on a second. Okay, I gotta set my 1 kilohertz to be 0 dB. So I click that. See, now that's at 0 dB. And now I can give a reading because that's my relative point. Okay, so our reference point is now at 1 kilohertz, 0 dBr. And on the right channel, you see where, well, it was slightly higher before, but it's about 1/5 of a dB down. And the left channel is like 6/10 of a dB down. Again, I think that's the RF shunting cap on the amplifier. The left channel must be a little more aggressive. It could be something in the amplifier itself, but really the only limiting thing on the high frequency for the amplifier is those RF shunting caps. They're ceramic, they probably have a pretty wide tolerance. Is it something I'm really concerned with? Not really, because you know, at 10 kilohertz they're really close together. But the main thing is now it is flat. The tone control is totally open. So if you want flat, you have to have the tone control fully clockwise. And yes, the balance control does have a 4th tap on it that is grounded right at the center. So I like to work these things out in my head. So what's going on here? When it's set to center, the wiper arm is also grounding. So that's 100K, so there's 50K load on each, so it's even. See, when you turn it to the side, now it's shunting this signal to ground. And when you turn it so it's down here, it's shunting this signal to ground. However, that tap keeps the load at the same level, that same 50 kilohertz, kilo ohms. That's why they're doing that. So when you turn that to the other side, it doesn't affect the these filters here or the signal level, because we got some impedance going on over here. Okay, yeah, I like trying to figure this stuff out in my head, so yeah, that's why they're doing that. 8 ohm power test. You can see here our distortion is much less than before. We were like around 0.8 in the other test. Now it's down to around 0.4. But yeah, we saw that earlier. And just over 2 watts it clips. It did the exact same thing before. And at 1%, it might be a little more now. It was 2.5 watts. It looks like it might be 2.7 or something. So Yeah, I kind of didn't expect a huge difference at 8 ohms. I'm hoping to see more at 4. So yeah, let's do that. 4 ohms is looking a lot better distortion wise, because in the last video we were over the 0.1 line at 1 watt, but now we're clearly under. We're around 0.7 or 8, or I should say 0.07 and 8. And at 1%, last time we were going across at 3. Now we're like 3.4. I was hoping it would be better over 4 watts, but we are limited by that power transformer. Not much you can do about that. It's kind of a small transformer. But with that heatsink, the nice thing is you can now use the amplifier with 4 ohm loads and do get a meaningful increase of power over 8, but nothing huge. Okay, I'm doing something a little different here. I cut the power to the amp, and I'm injecting power from my power supply set at 15 volts into the amp right across its filter cap. So it's being supplied with 15 volts, and I ran the distortion test at 4 ohms again. Much better. Look at that. 2, 3, 4, 5, around 5.4 watts or so now. So yeah, that little transformer is struggling to keep up with 4 ohm loads. Be nice if I could find one that's a little bigger but still fits in the amp, because that's really what this amp would need to get out of its weakness. I mean, it's not a powerful amp, but I would like to see 5 watts per channel come out of the thing with 4 ohm loads. That'd be nice. One thing you could do is do away with the internal power supply and put a jack on there and find like a, I don't know, a 14 or 15 volt transformer, and you have a much powerful amp. Absolutely, you want to make sure you heat sink it, because that's going to dissipate a lot more power than it does with the built-in supply that obviously under load puts out a lower voltage. Okay, the final measurement here is frequency versus distortion. I'm just going to measure this at 8 ohms and compare it to what I got before. If you remember in the last video, this line started going up here and it went above 1% at 70 hertz. It's that capacitive coupled rise in distortion you see in amplifiers. But with those much larger caps, we don't quite get to 1% distortion. You know, that's 20 hertz line right there. So huge improvement. And as we saw before, at 1 kilohertz, distortion is down to 0.04. Again, a significant improvement. And what I like with this amplifier, we don't get a huge rise. You know, we're only at around 0.2% at 20 kilohertz. So that's not too bad at all. So a pretty decent improvement with the distortion. Okay, I put the cover back on and cleaned it up. It looks really nice now. This tone control is really a high cut. Just keep it fully open for flat response. So was this a meaningful modification to this amplifier? I would say yes, but one objective kind of wasn't met. Really improved that lower frequency distortion, that capacitor rise as I call it. And along with that, the lower end frequency response is much better. Reduced the power supply hum that was getting into the signal. I think it was like minus 40 dB around there before, and then it went down to minus 65 dB with the larger cap helping that out. Removed the loudness compensation from the volume control. Had to do a little extra credit work to get that completely flat. If you're using decent speakers, I don't think you really need it. Just kind of coloring the frequency response anyway. I'd rather have the amplifier flat. Now we have 4 ohm capability. Adding the heat sink, the larger output coupling capacitors, give the amplifier some meaningful power gains with 4 ohm loads. One thing the modification really didn't accomplish is a gain in 8 ohm power. Yeah, it measured slightly more, but it's not really meaningful gain. If you want to get a little more out of this amplifier, I would go with an external supply. Build a 15 or 16 volt regulated supply. Use the LM317 regulator chip. With low overhead voltage, I think you can get 2 to 2.5 amps out of the thing, which would be plenty for this. And as we measured, you'd see a definite improvement in 4 ohm output power, and should even get a little more with 8 ohms. And also being regulated, you drop that power supply hum down even more. So there you go, some mods to a budget vintage Radio Shack amplifier. That'll do it for the video. Appreciate you watching. If you want to stick around, I'll hook this thing up to some speakers and give you a little sample listen. Okay, YouTube safe lounge music here, lounge jazz. I'll record it with my little microphone set up here. See how it goes.